fractions. This is when you have fractions that have different numerators. Remember, your numerators are your top numbers. And they have different denominators. Denominators are your bottom numbers, but they still can be worth the same amount. Think about this with money. Let's say somebody walks up to a register and they have a $10 bill, and then somebody else walks up to another register and they have two $5 bills. Even though it's going to look different, their value is going to be equal. So consider that when talking about fractions. They can have a different look to them, but still have the same amount. There's two ways to look at it. You can look at it as visuals, which we'll look at over here, or we can do something that I call cross multiplication. So let's start off with a visual. Visuals are the best way to look at it. So let me erase this, wasn't supposed to be there. Say we have 1/2, and we want to see how many fourths that's worth. Well, if we think about it with pizza, because that's the way I like to think about everything is with pizza, I have a pizza that's going to be cut into 2 slices. So say you order a pizza and this one's cut into 2 slices, and you decide to eat 1 whole slice. You created a visual for 1/2. But then you ordered another pizza, and it was cut into fourths. And you said, well, I want to eat the same amount of pizza. How many fourths is it going to take? Well, if I shaded 1/4, that's not the same amount of red I have over here. If I shade in another fourth, which would be 2/4, let's see if it'll let me. I have to drag it over. It's not going to be perfect, but it's going to be pretty close. It looks like I have almost the identical amount of red. So that means that 2/4 and 1/2 are equal to each other, even though they have different numerators and denominators. Now, you're not going to want to draw pizzas every single time you have a math problem, so we can check it numerically through cross multiplication. You're going to do that by multiplying your opposite numerator and denominators and seeing what you get. So if I start with this 2, I say, okay, what is 2 times 9? 2 times 9 is 18. I say, okay, let me multiply my opposite numerator and denominator. 3 times 6, well, 3 times 6 is 18. If your top numbers are equal, that means that your fraction is equal. So 2/6, somebody eats 2/6 of a pizza and somebody eats 3/9 of a pizza. They ate the same amount. Let's try another one. Multiply your opposite numerator and denominator. 4 times 10 is 40. Multiply your opposite numerator and denominator. 8 times 5 is 40. Hey, those top numbers are equal. That means my fractions must be equal. If somebody eats 4/5 of a pizza and somebody eats 8/10 of a pizza, they have the same amount. They ate the same amount. Now, what I want you to do is try out this example problem. So let's say somebody eats 3/8 of a pizza and somebody over here eats 4/5 of a pizza, and we want to know, are those equal or are those unequal, not equal? What I want you to do is take a couple of seconds or take a couple of minutes, try to work out either with visual or through cross multiplication if those two fractions are equivalent. Now that you're back, I'm hoping that you tried to work it out. I'm not going to show it visually just because that takes a big old chunk of time, but I can show it numerically. Multiply your opposite numerator and denominator. 3 times 5 is 15. Multiply your opposite numerator and denominator. 4 times 8 is, 32. If these numbers are not equal, then these numbers are not equal. But think about this. I wonder which person ate more pizza, the 3/8 guy or the 4/5 guy. Think about that and come back to me whenever we're talking about comparing fractions.